All right, so today what we're going to do is we're going to look at highest common factor. So first of all, we're going to evaluate those three words. You know what they mean, but you may not remember what they mean when they're all put together. First, I'm going to start at the end with factor. We defined factor last time we were here. A factor are things that are factors or things that are held together with what operation? Multiplication. Yeah, you can read this off your notes, guys. Come on. Yes, with multiplication. And we can also define them by the opposite way. What's the opposite of multiply? Division. So a factor can also be defined as anything that will divide evenly. Right? So that's also a factor. So like 3 times 4 make 12. They're factors of 12. But because 4 divides evenly into 12, we know it is a factor of 12. Right? So you can think of them both ways. If something is common, that means it occurs where? Everywhere. Right? Okay? So common means it occurs everywhere. And we're talking about numbers, so that means it's a factor that's going to occur in every number we're on our list. Generally, we're only looking at 2, but you can look at more. And finally, highest means the biggest possible one, right? Okay? So we want the biggest possible one. So the highest common factor, which is always abbreviated HCF, now, also known as a greatest common factor in my part of the world, so you're going to hear me go back and forth. Sorry about that, but y'all can deal with it. All right. Is simply the largest number, in this case, because we're only working with numbers. If it was algebra, it could be letters too. The largest number that will divide evenly into a given set of numbers. So the largest number that will divide evenly into a given set of numbers. And it's usually 2 numbers, but it could be more. You could have 3 or even 4. But it's not going to be that. You're going to get carried away, but usually it's 2. Okay? Now, lots of times it's easy to see what number will divide into them. If you had 2 numbers and they were both even, say if you had 24 and 36, they're both even, right? Which means they both divide by what? 2, right? An even number will divide by 2. But there's a bigger number that would divide into them. They will all both divide by 6 as well. And we want that biggest number possible. But instead of just groping around in the dark and trying to figure out what to do, we're going to look at this using something that we've already learned. Remember last time we were here when we were finding all of the prime factors, we used that repeated division thing. We're going to use the same process here to find these. But because we're dealing with more than one number, we're going to put both numbers or all 3 numbers in the same division symbol. Now you're going to see when the book does it, they do it slightly differently. If we were looking for example, the GCF for 34 and 36, they would do them separately and then see what factors they have in common and then multiply them all out and etc. It works. But kind of like the factor tree, it requires that you stay focused and organized when it's not really necessary. So instead of doing both of them separately, what we're going to do is we're going to do them at the same time. Because we know they're related anyway, yeah? Because we're looking for the GCF or HCF for them. So we know that we're looking for the biggest number that will divide into both. So we're just going to use both at the same time. So let's talk about steps. First step. Write the numbers in an upside down division symbol. Remember, we're using a division symbol, but it's upside down, right? Now, here's where you have to be sure that you're always very careful about when you're doing this, because you can't just start dividing away at pieces, okay? The next thing you want to say is, will anything divide into all of the numbers? Now, in this case, I only have 2 numbers. But remember, I said that you can do this with more than 2 numbers. So that's why I put all the numbers. So if it has 3 numbers, you're going to look to see, is there anything that will divide into all 3 of them? Because if you divided something out of 2 of them, when there was something that would divide into all 3 of them, then you're not going to get to the right answer. So you always have to see if there's something that will divide into all. Then you're simply going to continue to divide as long as something is common to at least 2 of the numbers. Pause for a moment. Once you've done all your division, right, you just stop so we're not going to take this all the way to 1 like we were doing when we did prime factors. You stop dividing when something stops dividing into both of them. I don't care what the numbers are on the bottom. It doesn't matter. Okay? You're going to multiply, and we know we need to multiply because they're factors, and factors are always multiply, right? You're going to multiply everything on the side to get the highest common factor or greatest common factor, whichever you like to call it. So everything that's on the side of the thing, that's where we got all those factors last time, right? They were on the side of the division symbol. We ignored the 1 at the bottom. Well, the number we get on the bottom this time is not going to be a 1 usually, but we're still going to ignore it. We're only interested in the numbers that are on the side. So let's look at this one. Okay? And it's generally easier to start off and think of prime numbers, but you don't have to, because some of you can look at 24 and 36 and see that 6 will divide into them. It's perfectly fine. You don't have to start with primes, but it's usually easier to divide by 2 and 3, right? So let's just start there. So what do you notice? 24 and 36 will both divide by 2, won't they? So let's divide. 24 divided by 2 is 12. 36 divided by 2 is 18. Good. Okay. Yeah. So here's the method they used. They did it side by side, and then they just matched up the things that were common. That's a lot more difficult than just doing it all together. So don't even worry about this. Don't worry about that at all. Let's try it. Let's try it the other way. So you can use workbooks now. We've got an example going on in the other. So what we're going to do is look at a few of these. Okay. Boring. How about J? We have 80 and 96. Just going to switch to notebook paper to make it look a little easier. So we want to find the HCF. Okay, guys? So we're going to put and close them both in the same upside down division symbol. And then we're just going to start dividing. But remember, you don't have to look. It doesn't matter that the numbers are bigger because we're going to start with what number? 2. So always start with small number, never 1. Okay. Both of these are even, so we know they'll divide by 2. Shh, guys. What's 80 divided by 2 going to make? 40. What's 96 divided by 2 going to make? 40. There you go. 48. Good. Okay. Now 40 and 48 will both divide by 2 again, so we're going to divide again by 2. So you get 20 and
24.
Good. Which will both divide by 2, so we're going to divide again. 10 and 12, which will both divide by 2, so we're going to divide again. We get 5 and 6. Anything divide into 5 and 6? Nope. So we're going to take all the stuff on the side, those 4 2s, 2 times 2 times 2 times 2, which is, anybody? There you go. So the highest common factor for them is 16. And again, if you had 80 over 96, what would it be as a reduced fraction? Yeah? Cool. All right, let's try another one. They don't have any with 3. Oh, well. But they have some applications of them, so let's look at it. So look at number 2. Farmer Giles has a field that is 45 meters by 60 meters. He wishes to divide it into square yards of equal size. What is the biggest size the yards could be? So, what we need to do is find out what factor is common to those. Now, this one's a slightly different. Okay, it's all right. So we're going to find out the common factors for those, and that means because if it's common, that means that we can divide it into equal parts, right? Squares have sides that are equal. Does that make sense? So let's see how we can divide 45 and 60 into equal parts. So we have 45 and 60. What do you notice immediately will divide into both of those?
5.
They'll both divide by 5. Good. Okay. So that gives you 9 and 12. We're doing this one. Then, what will divide into 9 and 12? 3. So which gives us 3 and 4. Anything common to 3 and 4? No. Okay. So that tells us, that tells us that 5 and 3 are the common factors. So 5 times 3 is what? 15. So that means that if he makes squares with equal sides of 15, then he can divide it into equal parts. Okay? Because they'll both divide evenly by 15. So like if this was 40 and this was 60, or 45, I'm sorry, that means he could make 3 of them across, 3 15s is 45, and he could make 4 of them down there, and they would be equal parts, squares. Make sense? 3 of them and 4 of them. Okay? All right. So it's also a division machine, too. So, looks good? So, here's good. This one has 3. Look at this one. A florist has 30 lilies, 42 gerberas, and 36 roses to make bouquets with. Each bouquet must be identical. So we need to divide them all into equal parts. In other words, find the highest common factor. Hold on a minute. So we're going to write them out. So we've got 30, 42, and 36. So what we're going to do is we're going to do them all at the same time. Do you notice anything that will divide evenly into all of them? 2. They're all even. Remember, you can't just divide by some of them. You have to divide by all of them if there's anything that will. So that's going to be 15, 21, and 18. We just did that one a moment ago, yeah? Is there anything that'll divide into 15, 21, and 18? 3. They'll all divide by 3. Excellent. Okay.
5.
Which gives us 5, 7, and 6. Is there anything that'll divide into 5, 7, and 6? No. So we know we're done. So take those two and multiply them together. So how many bouquets can he make? 6. Okay. And listen, watch this. And in each bouquet, where these were lilies, these were gerberas, and these were roses, right? Each bouquet is going to contain 5 lilies, 7 gerbers, and 6 roses. Who knew? Okay.
So why do you have the highest common factor?
Because what we're doing for the highest, we're trying to find out the biggest way that you can divide them all evenly. And the biggest, so that's the biggest factor that's common to all of them. Okay? All right. Now, I want to just show you this, guys. I don't know if they're ever going to do this to you, but look up here for just 1 second. Let's pretend, now this is pretend because it didn't happen, but let's pretend this was an 8. Now that's not really what happened though, right? When we looked at these, is there anything common to all 3 of these? Pick one, I don't care which one.
It was you. It was her.
So we're pretending it was an 8. It wasn't, right? But if it was, now there's nothing common to 5, 6, and 8, but is there something common to 8 and 6? That means you could continue to divide. You could divide those two by 2. Okay? Now, this is not what we were doing in this particular case, but I just wanted to show you that you could continue to divide if there was something common. Yes? That was a 7 right there. Okay? And 2 times 3 gave us 6 common. Okay, so what I'm going to do is I want you to go back to your snowflake book. So you're going to need your computer because you can't do them all. Nope. So I can't do them all. So what you're going to do is, ladies, come on.